Hey everyone,
Hey, Vijay.
how goes it? Happy Wednesday.
Happy Wednesday.
So yeah, I'm just having some tea right now, waking up. See we have
Morning.
yeah, just basically like we have us two here today. You and Sivam. I guess we can wait a few minutes. One thing I wanted to ask was, did we leave off last time like around here? I think, is that where we were handling node losses? Just refresh. I think we left probably around this point. Is that safe to say?
I think so. I don't remember honestly.
Okay. Well, we can always kind of recap a little bit before and then catch up.
Yeah. I have a hard stop at 8 today, so I'm only here for the first 25 minutes.
Okay. All right, no worries. When you have to leave, you just jump out.
Yeah.
And you can always resume later. Okay, so I guess I'll just recap a little bit. And then Ramya, I don't know, do you want to also join in the reading? I feel like you were reading last time, so I wasn't sure. But if you're away for some reason, then I'll just go ahead and do it.
I can continue reading. Sorry, I was talking to myself. I was unmuted.
Oh, okay.
Yeah.
All right.
Yeah.
Okay, great. So then I guess, do you want to just kind of recap a little bit from maybe here, and then we'll go forward?
Yeah. So
Okay.
the second part of the book is kind of looking into distributed data. When the data is in multiple nodes, what is the motivation to have data in multiple nodes? It talks about the brief motivation is one is scalability. We wanted to handle the data volume, read and write load. And the second is fault tolerance and high availability. We don't want to have a single node point of failure. And the third is latency. Like we talked about, if Netflix server is in India, we wanted to get streamed from the server close to a location so that users would have lower latency. Scalability, availability, and latency are the three main motivation for distributed data. And there was a brief introduction to vertical scaling and horizontal scaling. In horizontal scaling, we add more nodes to an existing system to increase the capacity or increase the availability or to reduce the latency. But in vertical scaling, is not useful for all three of this, right? Vertical scaling may simply address the first point, scalability alone, by going to a bigger machine. So vertical scaling doesn't address all 3 points, just the first point of scaling by going to a bigger machine, and it is expensive. This chapter talks about replication. Replication means that the same copy is in multiple data nodes for redundancy. This is orthogonal to partitioning, where partitioning is like the data doesn't fit into the disk of one node. So even the data itself is partitioned across multiple nodes. That's called sharding or partitioning. This was a brief introduction. And then when we came to replication, the motivation for replication was same, like reduce latency, increase availability, increase the read throughput. There are three major algorithms to do replication. One is like a single leader based, the second one is multiple leader based, and the third one is leaderless. And the techniques these three algorithms use for replication are called like synchronous and asynchronous replication. In synchronous replication, you wait until at least one of the followers also have the data during the write operation. Most of the databases have this configuration, or it is by default synchronous for one follower, and then they exit for a single leader distributed replication. And we saw like, yeah, this is the crux of it. Let me find my page. And the master node, or there are leaders and followers, and how they get the data change. The write always happens to the leader node, and it gets replicated to the followers either synchronously or asynchronously. The read always goes to the followers. So that's the crux of leader follower replication. Then they talk about data being in consistent state and the drawbacks of what is synchronous versus asynchronous replication. And yeah, now I think this is the crux of it. And the next section, they talk about setting up new followers. So how do we set up new followers? We typically don't do a data file copy. There is a snapshot. So every node will have a snapshot of its data at a particular time, maybe like an hourly snapshot or a couple of hours snapshot or whatever. Whenever we need to go to the set up a new follower, we latch on to the latest snapshot and then redo all the data operations and bring the server up, bring the DB server up. After all the snapshot contents are present in the follower node connects to the leader and requests the data changes that have happened since the snapshot was taken. Typically, there is a log sequence or some sequence through which it can identify, and it does a copy of it. It does request changes after the snapshot. So this is how we set up a new leader, a new follower. Take a snapshot and then connect to the leader after the snapshot has been enabled to get all the contents after the snapshot. Here is where last time there were a bit of discussions about the snapshot ID and all those things, how the snapshot ID does not overflow. I spoke to the DB admin in my office and how does he does snapshot for our use cases. Like snapshots are not forever, right? Their lifetime is limited to, let's say, a month or something like that. After that, they archive the snapshot and they can reuse the IDs from the previously archived snapshot, but it can differ from use case to use case and company to company on how they use it. I've not gone and read details about how, in general, snapshot ID is generated. Typically, it's a UUID or it's a logical timestamp, and since it is, and they can reuse the IDs because snapshots are not forever. They are archived after a certain time, and the archived snapshots from previous archive can be used. It is also a contract between the leader and follower, right? The leader will say, I have snapshots only for the last 10 days, not for the last 10 years, which is not practical with the growing data size needs. That's about it there. So now we can jump on to handling node outages, I believe.
Good stuff. Yeah, that makes it fresh. So I think we were here handling node outages.
Sure. Looks like someone also joined. Oh, Sadhana is also here. Great. Okay, node outages are important for achieving high availability. The motivation for why we have to handle node outages is availability. Let's say half of the systems in the distributed system goes down, then your availability goes down. So the motivation is to try to maintain the same availability. And how do we achieve this? They talk about a couple of failures. One is what happens when the follower fails. And the next section talks about what is the leader fails. If the follower fails, what happens is each follower keeps a log of data changes it has received from the leader. It's like in the previous chapters, we have always read that there is always a database log or a write log, right? Similar to that, here there is a write log to the follower. If the follower started and is restarted, or if it cannot contact the leader, the follower can recover quickly using these write logs. It knows the last transaction that was processed before the fault occurrence. Once it processes its own write log, then it is similar to the snapshot. It connects to the leader and collects all the transactions which happened after the failure time. So this is what happens to a follower recovery. Like the same follower goes offline for some time and comes back online. The next section talks about leader failure. Leader failure is a little more tricky than follower failure. Here, the leader is failed. It can writes cannot happen, right? Because there is no leader in the distributed system. So we have to make one of the followers a leader if the leader stays failed for a long time, and then choose a new leader. There is some election process going on, and these election processes are explained in the future chapters to elect a new leader. And after we elect a new leader, we have to reconfigure the entire system to write to the new leader, because we know, let's say there is a load balancer which handles the writes to all these in the system, right? Previously, the load balancer would have had the IP of the old leader which was failed, and the system had to reconfigure itself in order to write to the new leader. So these three are the fundamental steps. I'll go a little bit in detail in all these three steps. Determining that the leader has failed. There can be many conditions that could potentially go wrong, like crashes, power outages, network issues, and there is no foolproof way of detecting how a leader has failed. Typically, in a distributed system, there is this concept of heartbeats, where machines alive in a system send messages to each other. These are lean messages, like on our UDP or something, not TCP, because that takes a lot of packets, saying I am alive. They are called as heartbeats. And these heartbeats can be sent to either all of the nodes in a system or only a subset of nodes in a system, depending on the various heartbeating protocols we use, the system is configured to work with. So if any system or more than a few of any node or more than a few nodes don't detect a heartbeat of a leader for a certain period of time or for a continued period of time, it means that the leader has failed. They use techniques like exponential backoff. Like if the leader is supposed to send heartbeat, let's say once every minute, and it has not sent it, they will check, okay, after 3 minutes or 5 minutes, if the leader still has not sent, then they assume that the leader has failed. All other nodes in the system assume the leader has failed. This is a bit of a story around determining how the leader has failed. This happens in the future chapters, but I wanted to give a quick high level of how the leader failure is determined. Once we determine the leader failure, other nodes will go through an election process to elect a new leader. The brute force for electing a new leader is make the node which has the most recent data changes from the leader make the follower which has the latest changes from the leader as the new leader. This makes sense because we have to minimize the data loss during a new leader election process. Let's say some node does not have data, like for last 3-hour data, and if that becomes the leader, then it will cause system issues. The third step is reconfiguring the system to use the new leader. This is basically the load balancer or something which will now point to the new follower, the follower which became the leader, so that the client will interact with the new leader for the write process. And there are a ton of challenges in this leader failure mechanism. So the first one is if asynchronous replication is used, in the sense the new leader may not have received all the writes from the old leader before it failed. If the former leader rejoins after some time, the cluster after a new leader has been chosen, what would happen to those writes? Who is the like we have issues about, okay, now the one of the follower node has future writes, but the current leader node has only writes up to previous timestamp. So they say these are some of the critical issues. They didn't propose the solutions here. They are simply talking about the issues which can happen with the leader failure and the election process. And they say discarding writes is essentially dangerous in storage systems. Let's say a follower which has not caught up with the leader is made the new leader, then we have lost some rights, and it can cause issues. They have given a practical example on how this was an incident in GitHub where a MySQL server failed and the follower brought up there was some rights were missing, and it caused some private data to be disclosed to wrong users. The third point is in certain scenarios, there could be two nodes that they believe they are the leader. This is called as a split brain. And data, I don't think this is too much of an issue, because given that we always write to a load balancer, not to the actual node, and the load balancer is configured, both the leaders can accept writes, and there is no process for resolving conflicts. So I'm not too sure about how they bring this point up, but we can dwell deeper or have a discussion on this. Like, what are your thoughts?
I think this is a good one. I think this still is a valid point, just like the other two. So, yeah, we can always discuss it down the line. I think that just having the basics is fine for now.
Yeah, I think I can add a point here. So I remember they mentioned the leader election process. It can be the most caught up follower, or there can be a controller node which does the leader election. I think if there is a third thing like a controller node to ensure that at a time there can be only one leader, then this won't happen. But if there is just a leader election process, there could be a chance that, you know, the previous leader, it came back up and the new leader is also still there. And, you know, the weird situations, and the client still somehow have the references for the old leader being a leader. Yeah, multiple things, but this, yeah. I see this can happen.
Okay.
Yeah, yeah, exactly.
Yeah.
Nice. Okay. Next, to talk about how do you detect a leader failure, right? What is the timeout? There is no accurate timeout, because as we all know, in distributed systems, network failure is supposed to happen, and there could be a glitch in the network, and you might not be able to reach the leader node, or the leader node's packets on I am alive or the heartbeats would take longer than expected. So there is no easy solution for what is the right timeout before the leader is actually declared dead. For all the problems discussed above, there are no easy solutions, and the operations teams typically prefer to perform failovers manually for leaders, even if the software supports automatic failover. So critically, the issues like node failures, unreliable networks, and trade-offs around replica consistency, durability, availability, and latency are fundamental problems in distributed systems. I really like the last 4 lines where they summarized everything in like one sentence.
Yeah, for sure. This is a good reminder of what we're reading. Like every now and then, like you kind of forget how far you've come in this book.
Yeah. So we read about setting new followers and handling outages of leaders and followers. Followers was easier, and the leaders had a lot more issues, and they typically be preferred to do manually. Next, we'll look into implementation of replication logs. I think I kind of rushed through that section in the beginning of the chapter. How do leaders send the information, right? So there is some replication log. How does leader-based replication work under the hood? There are several mechanisms. And first one is like, I think there are 3 or 4 mechanisms: statement-based, write log-based, row-based, and trigger-based. What a statement-based is, suppose there is a database command that needs to get executed, right? This command itself is passed to the follower, like an insert, delete, or update command is passed to the leader. You can think of it as like a simple SQL command. and that command gets executed in the follower. On a high level, this looks simple and easy and reasonable, but what are some of the caveats? For example, if there is a non-deterministic function like a now, or even the timestamps in the local clocks, something based on the local clock of the node, or the random function, it will generate the query will generate a different value in each of the node. That is the first problem. And the second is, if we are using auto incrementing algorithm based on some conditions, they must be executed in the same order on each replica. We cannot guarantee that one, or the leader cannot guarantee that. Leader just sends these statements and wishes they get executed in the same order, but the execution order in the follower might be slightly different depending on how the packages arrive over the distributed network, right? Because of the delays and routing, some packages may arrive earlier. The earlier sent packages can arrive late, so the execution order of the statements can be different. And the third thing is, statements can have side effects, which may result in different side effects occurring on each replica because of all this non-determinism, using the order of the packages and also the time-related non-determinism. The workaround for these non-issues is leader can replace any non-deterministic function calls with the fixed return value when the statement is logged, so that the followers will get the same value. However, there are so many edge cases and other replication methods are now generally preferred. Though this is one of the simplest methods, it's not typically used. Statement-based replication was used in MySQL. It is still sometimes used today as it is quite compact, but by default, MySQL switches to row-based replication. VoltDB uses system-based replication, and it makes it safe by requiring transactions to be deterministic. Yeah. The next section is like on a write-ahead log. In chapter 3, we discuss storage engines represent data on a disk, and we have a write log for every transaction. There was a log structured storage engine using LSM trees, and there are B trees for databases. In either case, log is an append-only data structure. So
you
basically
okay?
Yeah. Sorry.
All right. Do you want to switch to someone else reading? I don't know, like
somebody else. Yeah. For a couple of, I'll get some water. Yeah.
Okay. All right. Sadhana, do you want to try? Or Siban?
I'm leaving in next 3 minutes.
Okay.
Yeah.
All right.
I haven't gone through the chapter, so I think Vijay has marked all notes. So
okay, great.
I can read for the next 3 minutes though. That's fine.
Yeah. Just give it a try. It's fun.
Yeah, sure. Yeah. I read what we are reading, so I'm
okay.
comfortable.
All right.
All right. So yeah, like Ramya was saying, right ahead log shipping is what a lot of database do. So yeah, logs are append only sequence of byte containing all writes to the database. So the replicas basically can use the same log to build the to basically create the data on the other nodes. But the problem with this approach is that the logs are very, very low level, and they are basically very tied to the software. So if let's say if a database is using this low level of replication, they cannot upgrade the versions without a downtime. So I'll just read what they say. This method of replication is used in Postgres, SQL, and Oracle, among others. The main disadvantage is that the log describes the data at very low level. Write ahead log contains details of which bytes are changed in which disk blocks. This makes replication closely coupled to the storage engine. If database changes its storage format from one version to another, it is typically not possible to run different versions of database software on the leaders and the followers. this is so like I said, yeah. So if they want to upgrade, they say, yeah, but it can be a big operational impact if replication protocol allows follower to use a newer software version than leader. You can perform a zero downtime upgrade of the database software by upgrading the followers and then performing a failover to make one of the upgraded nodes the new leader. But if the replication protocol does not allow this version which mismatch, which is the case with the write-ahead log shipping, so it needs a downtime. So moving on to the row-based log application, which actually looks like I have read till here. Yeah, okay. Should I just read along maybe?
Sure.
Yeah.
Just trying to get people practice with reading because I want to give everybody a chance.
Yeah.
So, but when you're done,
I'm
just
very
pass it
nice.
off. Yeah.
Yeah. Okay. So yeah, an alternative to use is the row-based log replication. So basically here we separate the replication log from the actual log that is being returned to the database. So the log that is sent to the replicas is a different log than what the log we are using to actually write to the to the storage engine. Now, with this approach, we have decoupled the replication process from the writing to the storage. So now with this, we can easily upgrade to different software versions because we are following a separate path to replicate the logs. Cool. So now, a logical log for a relational database is usually a sequence of records describing writes to the database table at granularity of a row, which means for an inserted row, the log contains the new values of all columns. For a deleted row, the log contains enough information to uniquely identify that the row was deleted. Typically, it can be the primary key. And if the table had no primary key, then it will log all the columns needed to be logged. And for an update row, the log contains enough information to uniquely identify the updated row, the new values of all the columns. It can be a transaction that modifies several rows, generates several. I think I'll hand off. It's 8 for me already, and I have not read. So I literally read line by line, which may not be.
Okay. Yeah. No, good job. No, that was fine. Okay. So it's kind of like you guys are failing, right? Like as nodes. And so like one of us is keeping like these highlights as, write ahead logs. So the next follower can like come up and become a leader. If you get the example I'm talking about here.
Yeah, this is what will happen when we are not updated.
Yeah. I always like to make like comparisons to like real world stuff because I feel like it makes more sense later on. Like I just remember it better. But yeah. It's funny. Okay, so I will just kind of continue here, and then Ramya, whenever you're ready, just let me know. But if you want to just kind of hang out, that's fine too.
Yeah, I can start from trigger based. So I'll let you finish the current section and I can start.
Okay. All right, so now we have a split brain going on.
If you like to continue, please go on. I can just.
Oh no, I'm just being funny, like using the stuff we learned.
Mm-hmm.
But it's actually good. I mean, like, so sometimes too, right? As part of the study group, I think, right, it's not enough to just kind of read these things because it's very dry. You have to kind of like make like, almost like parallels to like real things that you observe in real life too. Because in my opinion, like a lot of this stuff that is built out is probably based on these kind of real life scenarios, right? Like you're literally teaching like these machines how to behave like humans, and the whole concept of like a heartbeat, right? Like you were talking about the heartbeat. I've heard that term so many times, like too, like when I am just like in different meetings at work, and you'll be like, okay, what was the heartbeat like for this particular machine? Are we tracking that? What are the logs? Blah, blah, blah. So like a lot of this stuff still like, carries over. It makes a lot of sense when you think about it conceptually. And it allows you to kind of be creative too, like later on, like when you're thinking about like solving some of these problems, rather than just kind of like memorizing everything here, like kind of just think about it conceptually, think about like how you deal with your own issues, right? Like, your voice goes down, somebody else is like, listening to what you're saying ahead, and they're ready to, step up to the plate, right? Something like that. So it's all good stuff here. I'll just quickly note the chat. All right, Sibin left. So kind of, coming back to this, right? So, we had this write ahead log, we had statement-based replication. Now we're at row-based replication, which basically means like, you're looking at, each row and you're kind of determining like which values to, update or insert or delete as you go into a transaction. And then, those records are basically, replicated. So one example of this is MySQL, which has the bin log feature, which allows row-based application. So actually, when I was reading this, so I read like one time, then like I kind of go back and read again and then write highlights each time. So, but now I guess I'll just kind of like highlight as I go here. So if you haven't noticed, I've been doing that the entire time actually. But yeah, so logical logs are just decoupled from storage internals. And that way it forces things to be more backwards compatible. Logical logs are also easier for applications to parse. So this is along with that idea of decoupling, I think it helps, like if you're working with multiple systems, some systems may not use the same architecture. So you're kind of able to kind of give these instructions essentially to a different architecture. And then that allows you to not have to worry so much a little bit about like upgrades and downtime. So this kind of like skips that issue. So this is nice. It says here, this technique is also called change data capture. Okay. Ramya, did you want to do this part or do you want me to take over?
Yeah, I have notes for that. I can continue from trigger. Yeah.
Okay.
So all the previously defined techniques, statement-based log, write-ahead log shipping, and the logical row-based log replication, they are all implemented by the database system or configurable in the data system. And they are done for all the data. Trigger-based system is orthogonal to that. It is triggered by the user, and the user can choose which data to replicate and which not. For example, if you don't want your database to be replicated completely, you want only certain columns or certain rows to be replicated, then it's possible to set up a trigger-based replication. However, like for example, when a write or an update happens, there can be a trigger, and we can within the trigger we can say go and ship this data or ship this log to the follower or write into a new table. The process itself is quite complicated. It has a lot of overheads than the other replication methods because there's a lot of user involvement needed here. In order to, you have to write a lot of custom logic and the testing of that custom logic, and then testing across distributed systems, whether this custom logic would do the right things in order to enable a write or an update in another node. So due to this limitation, this is predominantly error prone and it's not typically used. Yeah, that's the crux of trigger-based application. Greater overheads, and it's more prone to bugs and limitations. So it is, however, it's more flexible. The next section talks about replication lag. Lag in the sense like if a write happens in one node, how long it takes for the write value to be replicated in all other nodes. Okay. 1 second. I read it like 2 weeks ago, so I'm just quickly scanning my notes.
Yeah, of course.
Yeah.
I think going back to this real quick, the trigger based,
Yeah.
it might be helpful to just kind of discuss, like the whole idea of what a trigger is right here. So I just made one more highlight here that says, for people who are not familiar with SQL, right, you can write custom code that allows you to do stuff, on a change of data. And that's usually called a trigger. It's like an event, if you're used to other languages like JavaScript or something. Triggers sometimes are used for logs and, like in this case, just sending another replication event. So this is kind of a feature of things like Oracle, Gate, or some of the other tools out there. Triggers are actually on most SQL database. You have that ability.
At least when I have used triggers, it will be like, the use cases where I have used is like, say we update one particular table and we need something to be updated in another table by some calculation, for example, or something like that. But I never imagined we could use that for, what do you say? Replicating the whole stuff to another node.
Yeah, I could see how this could be problematic though, like just kind of going into this next section, lag.
Yeah.
And then if you have to write a lot of custom code, like for each column, it just becomes kind of like spaghetti code in some ways, right? So that's like something else to not. I don't like this approach.
Everything on the application layer and not by the DB just provides us the infra to kind of utilize triggers. But the entire replication is now managed by the developer themselves.
Exactly. Yeah, it's not a good pattern in my opinion.
Yeah.
But who knows? Okay. All right. So now we can go into this, I think.
Yeah. So here they talk about replication lag. So the leader-based application, quick recap is it's useful for read-heavy application, and because the writes go through a single node and the reads can happen from all the other followers. However, the more the number of followers, even for an asynchronous replication, the system needs to take care to replicate the values to all the followers. This is the problem with the read scaling architecture. Synchronous, definitely it would block and it will increase your write latency. In asynchronous, you have to make sure even the 1000th follower is having the right correct value, but the value won't be present instantaneously. Eventually, the value will catch up, and this is this is the concept of eventual consistency. Consistency has many levels: stronger and weaker, and eventual consistencies. And eventual consistency is when at some time in the future, the value of the follower will catch up with the value of the leader. Even if the replication lag is only a fraction of a second, and or sometimes it's not noticeable in practice if it is a fraction of a second. But if the system is operating near capacity, or if this problem in the network, the lag can easily increase to several seconds or minutes. When the lag is large, the inconsistencies is introduced are not just a theoretical issue, but the problem for applications. Here we talk about 3 problems that are likely to occur when there is replication lag and outline some of the approaches to solving them. So basically the next section talks about what are the problems with the replication lag and how we can guard against those problems if possible. The first section talks about reading your own writes. Many applications let the user submit some data and then view what the user have submitted. For example, you're writing comments in any of the Facebook posts or any or a chat communication, right? You will be able to see your own writes. This is like reading your own writes. So what happens in this case, right? If your write will go through your leader database and your read will happen from the, in general, the principle if the read happens from the follower nodes, the follower you are assigned to might not happen the write. So it's, if you comment on a LinkedIn post and if you don't see your own comment, it's not a great user experience. So what typically happens here is when a user makes a write followed by a read, they try to make the read go through the leader itself for a certain time period before the replicas have caught up. In the sense, the read this ensures that the user can read what they have written. So user can read their own data after they have updated anything. And there are many techniques to implement the read after write consistency. When reading something that the user may have modified, read it from the leader, otherwise read it from the follower. That is like a fundamental rule. For example, like user can update the profile and one user profile is available only user will update the profile, no one else. So all the profile reading can happen through the leader. And the second point talks about that in most applications, whatever the edits are made by the user can go through the leader for a certain time period. Let's say like a minute or 2 minutes, whatever read can happen through the same leader. And within that, after the time period, the read for the client which initiated the write can go through the followers. The third thing is the client can remember the timestamp of its, I think I'm doing a bad job here. I have to go and probably read it one more time. I have some notes, but the notes are not very quick popcorn talk for here. I think I'm wasting everyone's time.
No, you're doing great. I want to just reiterate, you're doing great. I think we can, I think we may be kind of going a little bit too fast, but I want to ask everybody else that. I would actually like us to maybe just kind of do a little bit more discussion too, rather than reading. So, I mean, just in a nutshell, right? Like, what's everybody's takeaway? I guess like I'll just round robin here. Like Sadhana, what do you think like so far about?
Yeah, the last section was pretty clear. So reading your own rights was pretty clear. So it's like we have to, I mean, say I'm the author and I go ahead and comment in some Facebook page or some profile editing, all of those things. So it isn't a great experience if first time I see my comment being present, later on if it goes to a follower where it is not being replicated, right? If I'm not seeing it, then I'm really confused whether it is replicated or not. So the idea behind always going to the leader for some time before the requests are routed to the follower is a good strategy. So that part is fine. So maybe we may want to go back and then talk about, I think the trigger based was also pretty simple, I think. So that's what we were discussing about. So maybe this part I have to, the first one I think I understood. So that is more to do like if we are having some deterministic non-deterministic functions like now or any kind of a sequence numbers, all of those things, right? So it so happens that it may not, at least the example of now is a very easy thing to imagine, right? So two nodes may not be synchronized at the same time. So there might be a certain difference. So of course the leader and the follower will have different data. So that's not something which is desirable.
Yeah. So, how do you feel about the terms, right? So we have statement-based replication, write-ahead log. And then, we have logical, row-based. Do these terms, like, are they new for
Yeah,
you? Or
yeah, we'll have to. I'll have to see how we can kind of at least the write ahead log was something we have already read about it in the
chapter
previous
3?
chapters, right?
Mhm.
So uh, that also seems to be okay, but I can
Do you
use the.
remember? Do you
Mhm.
remember the B tree and the log tree? I mean, the log structured in storage engine, LSM.
Yeah. If you ask me, I'll have to try to. What do you say? Pause a bit and then try to get it from my hard disk, not even cache.
Yeah, yeah. These are two things that we kind of went over a lot in chapter 3, and I
Yeah.
guess maybe just would be good to review LSM and B trees.
This was that log structured merge trees, right? So we had um, write ahead logs. So it was like append only logs. And
Mhm.
then B trees, I think we have spoken how exactly B trees work. So how do they use it? So all these particular logs are being sent to the followers for replication, is it? The
That's right.
replication is
Yeah.
okay. We use the exact same log to build a replica besides writing the log to the okay. So it's like that's so now tell me, this is again a log based replication, right? When I say log based replication, right, it is like write ahead log is like it typically says what is the operation a particular statement was asked to do, kind. So
Right.
that is exactly what we go ahead and put it in the write ahead log, so that even if the same node um, crashes before we dump the entire contents in the memory onto the disk, we use this particular write ahead log to build up the entire structure. So the same thing can be used to replicate.
Right. Exactly. So this is very, very straightforward, simple, right?
Yeah.
Statement-based replication is just exactly right. The statements, what did you do? I
Pass the
inserted, and then
statements.
the database copied that. But there are problems with that because of the non-deterministic functions.
Yeah.
Whereas this is a log, and this is what we've been used to so far in the previous chapter discussions. But
Yeah,
then,
this one yeah, maybe we just have to go through the have to refresh a bit on the
Mhm.
disadvantage which came in, right? I think this is where Ramya was talking about two different versions. Say leader is in a different version of storage engine and the follower is in a different version. Is that
exactly.
this one?
Mhm. That's exactly right. So
Yeah.
the log gives low level instructions on how to rebuild, and that can cause a lag like when the follower is trying to rebuild. But if for whatever reason, and this probably does make sense. I mean, like if there are followers on other external systems, right, for some reason they're using a different version, then that could screw up stuff.
Go back a bit, Vijay. So this is where we were talking about what do you say? Block wise, whatever is written. The main disadvantage is that the log describes the data at a very low level.
Right.
Write ahead log contains the details of which bytes were changed in which disk blocks. Okay, so they actually go to that low level detail where they kind of point out, okay, hey, in this particular disk block, so and so byte was changed. So the same thing, they go ahead and send it to another node which is running a different version. Of course, there is going to be some
Yeah.
uh,
Mhm.
errors.
Right. Right. And then the last one is this row based where it's just trigger based. And remember, triggers are just like events. So essentially, you have like this.
No, here
Actually,
it looks
I'm
like
so I jumped ahead. Sorry.
yeah.
This is row based. Sorry, there's
So
also
yeah,
trigger based over here.
yeah,
Okay.
yeah. In the row based looks like they just have information about what needs to be updated. Say, for example, in order to insert a row, you will need all the values. In order
Mhm.
to delete a row, whatever is the primary key should be sufficient. So in order to update the row, all the modified contents is being sent across. So that way we will be able to replicate it. So when I send the entire set of values, so yeah, of course, there should be some indication to say whether it is an, I would expect to indicate whether it is an insert operation or a delete operation or an update operation. What do you all think? I mean, I don't know, vaguely sending only the values might not
Well,
be
it's like a test, right? In some ways, this is the expectation. And so when the replication does its own algorithm process, it should match up with whatever the value, expected value is, for each of these. That's what my takeaway is, at least.
Come
Yeah,
again? Sorry, I missed that last point. I did not understand it completely. What did you say?
Me or Ramya?
No, go ahead. Go ahead.
Oh, so essentially, like he's talking about being decoupled, right? And so there is a logical log which kind of is a sequence of records, right? Like he says here,
Yeah,
describing rights to the
let's
database.
Say, for example, let's take an example of a table which contains 3 columns, A, B, C, for example, right? Onto which we go ahead and insert 1, 2, 3.
Right. So you would expect 1, 2, 3, like for the next replication. And then it's the job of the machine to do that.
I mean, in the log, we will write it as only 1, 2, 3. I mean, what I'm trying to say is, along with 1, 2, 3, right? It probably needs to indicate whether it is an insert operation. And again, if A is the primary key for that particular table, right? So just writing 1, or will it be delete 1? So that's what I was kind of wondering.
Oh, yeah, well, definitely like, and I think we need more information here, but like, I think like it would just capture.
Because what will happen is like, what I'm thinking is like, say again, the leader and the follower, they are running different versions of a particular table schema. Say, for example, previously there was ABC column in both of them. And say, for example, how do I put it? Okay, let's imagine both of them had the columns A, B. Both of them had the columns A, B, assume, right? And assume for some reason both had to be a unique combination. Both of them had to be a primary key combination, right? Now, only in the leader, if we go ahead and add a new column, or rather the other way around, if we go ahead and delete one column, right? How do we tell the other guy? I mean, there shouldn't be any confusion, right? There should be some indication to say this is the operation. So there can be scenarios. What I'm trying to say is I'm not able to get a good example, but what I'm trying to say is it can lead into confusion if you just send only the values. It can be misinterpreted, like whether it is an insert or is it an update, or is it actually going, okay, delete again might not be the right example, but yeah, insert or an update, there might be some kind of an
yeah,
confusion.
For sure, yeah, of course. If you only send values, yeah, then you're going to have confusion. I think like it's also keeping track of the actual command itself.
A transaction that modifies several rows.
The transaction, that's correct. That's the right term. The transaction, it's keeping a track of those transactions.
Several rows that generates followed by a record that the transaction was, okay. So it's like, yeah, multiple rows are, okay, say we do some operation to modify X number of rows. So that X number of rows is now replicated to the other one, and it is put inside a transaction so that it remains atomic kind.
Right. And we may need more information here. I think this part maybe he might be glossing over it. But I think the idea is that when you keep track of just like what the values and the transaction should be, then it's more backwards compatible, because like you don't have to worry about which version some database may be as compared to the others, which again, this one is more low level. This can break because of different versioning. this one is just, like this one is statements, which I think, this is like having the command without the value. So the value can like vary. This is just kind of keeping track of like the value and the transaction. At least in my opinion, that's what I think he's saying, but I could be wrong. And I guess it's called change data capture. And I guess, like you said, we'll have more information later. And then finally, there was the trigger based, right? Which I think we were saying is kind of like this event based column, architecture, which could also not be that great. So yeah, I think we're in a good spot here. I know this is a really long chapter. I understand. I'm right there with you all. When I was reading, I was like, my God, this is like 50 or 60 different pages. So it's not an easy read.
Yeah.
Just go through it, take your time. What I think like we should probably care about more is just just being able to digest it, because otherwise if you just read it, you're just kind of like letting it go in one ear and then come out the other ear, and that's not good. So
yeah, I think I missed the first 10 minutes. So maybe anyways, we just have 1 more minute. So somebody can summarize that first 10 minutes, right?
Yeah, of course. So I think we were right here at the beginning. So we were talking about like failure, right? And so there's 2 types of failures. One is follower failure and the other is leader failure. And then just kind of like how you achieve replication based on these kind of failures. Failures can be things like, systems go down or systems pausing or whatever, right? So that was kind of like this whole concept of a heartbeat, like monitoring, like whether that's, machine is still up or down. If a follower dies, it's actually kind of simpler, because you can just replace it with another follower. The followers like also can restart just based on the snapshot that they had, and then they can kind of, get back up to speed. If the leader, dies, then you have more tricky situations, right? Like you have to determine how the leader failed, then choose a new leader, then reconfigure the system to use a new leader. It's kind of like when Ramya started like coughing a lot, right? And we were like, oh no, she's dying.
I think I missed something before that.
Okay. So I think
It was a recap, right? Before that, we just recapped what we did last.
Yeah.
Okay.
Yeah.
The main I think we weren't that far off. Like, so the beginning is just this whole idea about replication. And it kind of resumes like some of the thoughts from the first chapter, like availability, durability, basically like those important concepts that, we want to be able to achieve.
And I think we last time we stopped at the point where we were trying to discuss more on how a snapshot is taken and how can a follower, what do you say, given a snapshot, how can it say deterministically say, okay, this is till here, I have all the data, and post this, I need all the data, whatever was gone into the leader kind. So we wanted to kind of dig deeper into the snapshot way in which the snapshots are designed. How exactly, I think how do you uniquely identify a snapshot, all of those things, right?
Right. I think we still need information on snapshots, but I think like just at a high level, we're kind of talking about the idea of a snapshot being maybe like a binary, like set of data that, like says, okay, I finished up to here, here's where I was, tell me what else I need to do so I can reconstruct myself at that level, back up to the database level. I sometimes think about this too, like, and I know we're at time, but like, how like people take pictures today, like with their phone, and then like we expect, like the phone to like, instantly get this image and share it to somebody else, and then that person be able to see that image, and you're just like doing this all the time without thinking. I was thinking, like, how do they keep all of this? Like when somebody like Apple or Google says, oh yeah, store unlimited photos in the cloud, right? Like, how does that actually work, right? Like maybe, they're just taking these snapshots, right? Because you can't keep the entire JPEG in the cloud, right? So like maybe these snapshots are just very, very like condensed binary formats, right? And then, as soon as you share it, it goes through that, translation process. And then the phone itself is like what reads this, whole sequence and then generates that image for you. The phone is powerful enough to create the image, right? But like transfer or storing it somewhere else, it's just these big blocks of like binary blobs, or not even blobs, just very, very like condensed numbers. So I don't know. I guess like going, like for me, I was just sort of thinking about that too. Like, how do they, when I was reading this chapter, I guess like in my mind, I was thinking about how do they like keep all this and replicate it and shard it. So maybe if somebody, I can actually do this myself. I can probably like go and read about it and see if I could share that at the next study session, because I think it's a good, interesting problem. It's relevant.
Yeah. I asked my DB admin how they do snapshot for our use case. And he mentioned the snapshots are not infinite, right? You will have snapshot only for the last X days or whatever time period it is defined to. So you can reuse the snapshot IDs. It's a rolling counter. So let's say snapshots are stored only for the last week. And after that, it goes into an archive, and that's a different mechanism for recovery from archive, which is very rare or almost not done. And for snapshots, after that, like let's say the first snapshot goes into the archive as a sliding window fashion, and the snapshot ID of the first snapshot can be reused by future snapshots.
So what is the format of the snapshot naming convention as such, Ramya? So it's like some ID followed by some date or something like that, is it?
It's typically a hash of an ID followed by some timestamps. Sometimes they don't use timestamps and they simply use a rolling counter, like a incrementing counter, right? For example, let's say 7 days, 7 shots not. So the value goes from 0 to 6 and again goes from 0 to 6. So after 6, when the value goes to 0, it will be like the next day. So you will have snapshots from 7 days before or something like that. So depending on the use case, it can be a UUID, or it can be a hash of the timestamp and a UUID, or it can be a incrementing counter, simply an incrementing.
Yeah, incrementing counter along with date, or only an incrementing counter. So
yeah, it's long that I took a distributed system course. I have to go back, and there were chapters in that, but it's been like 5 years since from the grad school, and I've forgotten most of the stuff.
Okay, well, I think it's a good place to stop. Like, good work to all of y'all. I think just keep trying to read ahead. Remember now we've got this system where we're reading this book and then we're reading the other book by Alex Shu. So in theory, you have a little bit more time to read through this. But that said, don't feel like you have to be pressured into reading. It's just the whole point of the group was just to keep us accountable so that we actually finish and like achieve the goal of learning system design. So that's all it is. But you can definitely use this hour block that we have, hour and a half, sometimes, to just kind of read along. I don't mind if we spend sometimes just reading along. I don't expect everybody to be always prepared. I think like, we have this hour for ourselves to basically either read together or at least discuss, or somebody can also just kind of like, be prepared and read. So all three are okay.
Cool. See you on Friday then.
Yep.
Oh,
See you on Friday.
Yep. Thank you. Bye.
Okay.
Bye.
Bye. Bye.